well, let's actually start in learning Lisp now. Actually, we'll start out by learning something much more important, maybe the very most important thing in this course, which is not Lisp in particular, of course, but rather a general framework for thinking about languages that I already alluded to. When somebody tells you they're going to show you a language, what you should say is, all right, what I'd like you to tell me is what are the primitive elements? What does the language come with? Then, what are the ways you put those together? What are the means of combination? And what are the things that allow you to take these primitive elements and build bigger things out of them? What are the ways of putting things together? And then, what are the means of abstraction? How do we take those complicated things and draw those boxes around them? How do we name them so that we can now use them as if they were primitive elements in making still more complex things, and so on, and so on, and so on? So when someone says to you, gee, I have a great new computer language, you don't say, how many characters does it take to invert a matrix? Right? It's irrelevant. Right? What you say is, how, if the language did not come with matrices built in or with something else built in, how could I then build that thing? What are the means of combination which would allow me to do that? And then what are the means of abstraction which allow me then to use those as elements in making more complicated things yet? Right, well, we're going to see that Lisp has some primitive data and some primitive procedures. In fact, let's really start. Here's a piece of primitive data in Lisp. Let's see. Right. Number 3. Actually, if I'm being very pedantic, that's not the number 3. That's some symbol that represents Plato's concept of the number 3. Right? And here's another. Here's some more primitive data in Lisp. Right? Right? 17.4, actually some representation of 17.4. And here's another one, 5. Here's another primitive object that's built in Lisp. Addition. Actually, use the same kind of pedantic. This is a name for the primitive method of adding things, just like this is a name for Plato's number 3. This is a name for Plato's concept of how you add things. Right, so those are some primitive elements. I can put them together. I can say, gee, what's the sum of 3 and 17.4 and 5? And the way I do that is to say, let's apply the sum operator to these 3 numbers, and I should get, what, 8, 17, 25.4. So I should be able to ask Lisp what the value of this is, and it'll return 25.4. Let's introduce some names. This thing that I typed is called a combination. And a combination consists in general of applying an operator. So this is an operator to some operands. These are the operands. And of course, I can make more complex things. The reason I can get complexity out of this is because the operands themselves, in general, can be combinations. So for instance, I could say, what is the sum of 3 and the product of 5 and 6 and 8 and 2? And I should get, let's see, 30, 40, 43. So Lisp should tell me that that's 43. Forming combinations, well, is the basic means of combination that we'll be looking at. And then, well, you see some syntax here. Lisp uses what's called prefix notation, which means that the operator is written to the left of the operands. It's just a convention. And notice it's fully parenthesized. And the parentheses make it completely unambiguous. So by looking at this, I can see that there's the operator, and there are 1, 2, 3, 4 operands. Right? And I can see that the second operand here is itself some combination that has 1 operator and 2 operands. Parentheses in Lisp are a little bit, well, are very unlike parentheses in conventional mathematics. In mathematics, we sort of use them to mean grouping. And it sort of doesn't hurt if sometimes you leave out parentheses if people understand that that's a group. And in general, it doesn't hurt if you put in extra parentheses because that maybe makes the grouping more distinct. Lisp is not like that. In Lisp, you cannot leave out parentheses, and you cannot put in extra parentheses. Right? Because putting in parentheses always mean exactly and precisely, this is a combination, which has meaning. Apply an operator to operands. And if I left this out, if I left those parentheses out, it would mean something else. In fact, the way to think about this is really what I'm doing when I write something like this is writing a tree. So this combination is a tree that has a plus, and then a 3, and then a something else, and an 8, and a 2, and then the something else here is itself a little subtree that has a star and a 5 and a 6. And the way to think of that is really what's going on are we're writing these trees, and parentheses are just a way to write this two-dimensional structure as a linear character string. Because at least when Lisp first started and people had teletypes or punch cards or whatever, this was more convenient, and they couldn't. Maybe if Lisp started today, the syntax of Lisp would look like that. Well, let's look at what that actually looks like on the computer. Right here, I have a Lisp interaction set up. There's an editor, and on the top, I'm going to type some values and ask Lisp what they are. So, for instance, I can say to Lisp, "What's the value of that symbol?" That's 3. And I ask Lisp to evaluate it, and there you see Lisp is returned on the bottom and said, "Oh, yeah, that's 3." Or I can say, "What's the sum of 3 and 4 and 8? What's that combination?" And ask Lisp to evaluate it. Right, and that's 15. Or I can type in something more complicated. I can say, "What's the sum of the product of 3 and the sum of 7 and 19 and a half?" And you'll notice here that Lisp has something built in that helps me keep track of all these parentheses. Watch as I type the next close parentheses, which is going to close the combination starting with the star. The opening one will flash. There. Here, I'll rub those out and do it again. Type close, and you see that closes the plus. Close again, that closes the star. Right now I'm back to the sum, and maybe I'm going to add that all to 4. That closes the plus. Now I have a complete combination, and I can ask Lisp for the value of that. That kind of paren balancing is something that's built into a lot of Lisp systems to help you keep track, because it is kind of hard just by hand doing all these parentheses. There's another kind of convention for keeping track of parentheses. Let me write another complicated combination. Let's take the sum of the product of 3 and 5. I'm going to add that to something, and now what I'm going to do is I'm going to indent so that the operands are written vertically. It's the sum of that and the product of 47 and let's say the product of 47 with the difference of 20 and 6.8. That means subtract 6.8 from 20. Now you see the parentheses close the minus, close the star, And now let's get another operator. You see the Lisp editor here is indenting to the right position automatically. Help me keep track. All right, here, do that. Again, I'll close that last parentheses again. You see it balances the plus. All right, now I can say, what's the value of that? All right, so those two things, indenting to the right level, which is called pretty printing, and flashing parentheses, are two things that a lot of Lisp systems have built in to help you keep track, and you should learn how to use them. Okay, well, those are the primitives. There's a means of combination. Now let's go up to the means of abstraction. Right, I'd like to be able to take the idea that I do some combination like this and abstract it and give it a simple name so I can use that as an element, and I do that in Lisp with define. So I could say, for example, define A to be the product of 5 and 5. Right? And now I could say, for example, to Lisp, what is the product of A and A? Right, and this should be 25, and this should be 625. And then, crucial thing, I can now use A. Here I've used it in a combination, but I could use that in other more complicated things that I name in turn. So I could say define B to be the sum of, we'll say, A and the product of 5 and A. And close the plus. Well, let's take a look at that on the computer and see how that looks. Right, so I'll just type what I wrote on the board. I could say define A to be the product of 5 and 5. And I'll tell that to Lisp. And notice what Lisp responded there with was an A in the bottom. In general, when you type in a definition at Lisp, it responds with the name, the symbol being defined. Now I could say to Lisp, what is the product of A and A? It says that's 625. I can define B to be the sum of A and the product of 5 and A. Close a paren, closes the star. Close the plus, close the define. Lisp says, OK, B, there on the bottom. And now I can say to Lisp, what's the value of B? And I can say something more complicated, like what's the sum of A and the quotient of B and 5. That slash is divide, another primitive operator. Here I've divided B by 5, added it to A. This says, OK, that's 55. All right, so there's what it looks like. There's the basic means of defining something. It's the simplest kind of naming, but it's not really very powerful. See, what I'd really like to name, remember we're talking about general methods. I'd like to name, the general idea that, for example, I could multiply 5 by 5. Or 6 by 6. Or 1001 by 1001. 1001.7 by 1001.7. Right? I'd like to be able to name the general idea of multiplying something by itself. Well, you know what that is? That's called squaring. And the way I can do that in Lisp is I can say define to square something x, multiply x by itself. And then having done that, I could say to Lisp, for example, what's the square of 10, and Lisp will say 100. See, now, let's actually look at that a little more closely. Okay. Right, there's the definition of square. To square something, right, multiply it by itself. Right, you see this x here. Right, that x is kind of a pronoun, which is the something that I'm going to square. Right, and what I do with it is I multiply x, right, I multiply it by itself. Right. Okay. Right, so there's a notation for defining a procedure. Actually, this is a little bit confusing because this is sort of how I might use square, and I say square of x or square of 10, but it's not making it very clear that I'm actually naming something. So let me write this definition in another way that makes it a little bit more clear that I'm naming something. I'll say define square to be lambda of x times x. Right. Here I'm naming something square. Right? Just like over here I'm naming something a. The thing that I'm naming square, here the thing I named a was the value of this combination. Here the thing that I'm naming square is this thing that begins with lambda, and lambda is Lisp's way of saying make a procedure. Let's look at that more closely on the slide. The way I read that definition is to say I define square to be make a procedure. That's what the lambda is. Make a procedure with an argument named x, and what it does is return the result of multiplying x by itself. Now, in general, we're going to be using this top form of defining, just because it's a little bit more convenient, but don't lose sight of the fact that it's really this. In fact, as far as the Lisp interpreter is concerned, there's no difference between typing this to it and typing this to it. And there's a word for that, word, sort of syntactic sugar. What syntactic sugar means, it's having somewhat more convenient surface forms for typing something. So this is just really syntactic sugar for this underlying thing with the lambda. And the reason you should remember that is don't forget that when I write something like this, I'm really naming something. I'm naming something square, and the something that I'm naming square is a procedure that's getting constructed. Okay, well, let's look at that on the computer too. Okay. So I'll come in, I'll say define square of x to be times x, and I can I'll tell Lisp that. It says square, so I've named something square. And now having done that, I can ask Lisp for what's the square of 1001. Or in general, I could say what's the square of the sum of 5 and 7. Right? Square of 12 is 144. Or I can use square itself as an element in some combination. I can say, what's the sum of the square of 3 and the square of 4? Right? 9 and 16 is 25. Or I can use square as an element in some much more complicated thing. I can say, what's the square of the square of the square of 1001? There's the square of the square of the square of 1001. Or I can say to Lisp, what is square itself? What's the value of that? And Lisp returns some conventional way of telling me that that's a procedure. It says compound procedure square. Remember, the value of square is this procedure, and the thing with the stars and the brackets are just Lisp's conventional way of describing that. Okay, let's look at two more examples of defining. Here, on this, right, here are two more procedures. I can define the average of x and y to be the sum of x and y divided by 2. Or having had average and mean square, having had average and square, I can use that to talk about the mean square of something, which is the average of the square of x and the square of y. So for example, having done that, I could say what's the mean square of 2 and 3, and I should get the average of 4 and 9, which is 6.5. The key thing here is that having defined square, I can use it as if it were primitive. Right? So if we look here on the slide, if I look at mean square, right, the person defining mean square doesn't have to know at this point whether square was something built into the language or whether it was a procedure that was defined. And that's a key thing in Lisp, that you do not make arbitrary distinctions between things that happen to be primitive in the language and things that happen to be built in. The person using that shouldn't even have to know. So the things you construct get used with all the power and flexibility as if they were primitives. In fact, we can drive that home by looking on the computer one more time. We talked about plus, and in fact, if I come here on the computer screen and say what is the value of plus, notice what Lisp types out. On the bottom there, it typed out compound procedure plus. Because in this system, it turns out that the addition operator is itself a compound procedure. And if I didn't just type that in, you'd never know that, and it wouldn't make any difference anyway. We don't care. It's below the level of the abstraction that we're dealing with. So the key thing is you cannot tell, should not be able to tell, in general, the difference between things that are built in and things that are compound. Why is that? Because the things that are compound have an abstraction wrapper wrapped around them. Okay, we've seen almost all the elements of Lisp now. There's only one more we have to look at, and that is how to make a case analysis. Let me show you what I mean. We might want to think about the mathematical definition of the absolute value function. So I might say the absolute value of x is the function which has the property that it's negative of x for x less than 0, it's 0 for x equal to 0, and it's x for x greater than 0. And Lisp has a way of making case analyses. Let me define for you absolute value. Say define the absolute value of x is conditional. Right? This means case analysis, cond. Okay. If x is less than 0, the answer is negate x. Right, what I've written here is a clause. This whole thing is a conditional clause, and it has two parts. This part here is a predicate, or a condition. That's a condition, and the condition is expressed by something called a predicate, and a predicate in Lisp is some sort of thing that returns either true or false. And you see Lisp has a primitive procedure less than that tests whether something's true or false. And the other part of a clause is an action, or a thing to do, in the case where that's true. And here what I'm doing is negating x. The negation operator, well, the minus sign in Lisp is a little bit funny. If there are two or more arguments, if there's two arguments, it subtracts the second one from the first. We saw that. And if there's one argument, it negates it. All right, so this corresponds to that. And then there's another con clause. It says, in the case where x is equal to 0, the answer is 0. And in the case where x is greater than 0, the answer is x. Right, close that clause, close the cond, close the definition. There's a definition of absolute value, and you see it's a case analysis that looks very much like the case analysis you use in mathematics. Okay. There's a somewhat different way of writing a restricted case analysis. Often you have a case analysis where you only have one case, where you test something, and then depending on whether it's true or false, you do something. And here's another definition of absolute value, which looks almost the same, which says if x is less than 0, the result is negate x. Otherwise, the answer is x. And we'll be using if a lot. But again, the thing to remember is that this form of absolute value that you're looking at here, and then this one over here that I wrote on the board, are essentially the same. And if and cond are, well, whichever way you like it. You can think of cond as syntactic sugar for if, or you can think of if as syntactic sugar for cond, and it doesn't make any difference. A person implementing a Lisp system will pick one and implement the other in terms of that. And it doesn't matter which one you pick. Okay, why don't we break now and then take some questions? How come sometimes when I write define, I put an open paren here and say define open paren something or other, and sometimes when I write this, I don't put an open paren? Okay, the answer is this particular form of define, where you say define some expression, is this very special thing for defining procedures. But again, what it really means is I'm defining this symbol square to be that. So the way you should think about it is what define does is you write define, and the second thing you write is the symbol here, no open paren, the symbol you're defining, and what you're defining it to be. That's like here and like here. That's the sort of the basic way you use define. And then there's this special syntactic trick which allows you to define procedures that look like this. So the difference is it's whether or not you're defining a procedure.